Welcome to Internet Broadcast Project. My name is Libia Martin Sekharume. I'm a mathematics teacher at Hudisa Technical School. I taught mathematics grade 12 from 1994 to date. And the topic for today is going to be trigonometry. We are specifically going to deal with trigonometric equations. And before we can do anything, I think it is important for us to know our three trig graphs. And I'm having the three graphs here. The first one is the one of y is equals to sine x. The second one is y is equals to cos x. And the third one is y is equals to tan x. Now, we are going to find the general solutions. Why do we need the general solution? It's because if we consider the graph of sine x, you see the pattern goes like this. We are having the y value as 0 here. We have got 1, we have got 0, we have got -1, we have got 0, we have got 1, we will have 0, we will have -1, we will have 0. As you can see, we can draw this curve up to infinity. Now, we need the solutions. If we need any number of solutions, we must make use of the general solutions. Now, we are going to have one question here, a question from this. Suppose we want to find the solution for, we make y to be 0,5. If we make y to be 0,5, then it means we are going to draw a horizontal line here. And as you can see, this horizontal line here is going to cut this graph of y is equal to sine x at this point, at that point, at that point, and at that point. But if we keep on drawing this curve up to infinity, we'll have an infinite number of solutions for this particular problem, which is sine x is equal to 0,5. Now, how do we get the general solution for the problem sine x is equal to 0,5? We are going to write it sine x is equal to 0,5. And if we look at our graph here, we can estimate the solutions for that. I've actually drawn this graph so that I'm having the multiples. I've used the square grid and I've used the multiples of 30 degrees. And obviously, if I look at this, 30 degrees is going to be one of the solutions because we want to solve x where y is 0,5. We look again at this other point here. We are having 150 degrees as a solution. We go to this position, to this point as well. This is -210 degrees. And we go to this point again. We are having this point as -330 degrees. But now, it will not be always the case that you have the square grid in front of you, or you've got the chance of drawing that particular graph. And how do we go about that? Now, we are having sine x is equal to 0,5. The first step that we must do is to identify the quadrant where sine is positive, because the 0,5 is the ratio of the opposite side over hypotenuse side, which is positive. Now, if we use our Cartesian plane, they normally have some clues for this, and the recent one that I've heard is all stupid teachers So all these ratios are positive in the first quadrant. In the second quadrant is only sine and its reciprocal, which are positive. So we are going to confine ourselves, when we solve this trigonometric equation, we are going to confine ourselves in the first quadrant and the second quadrant. So step one, we have identified the quadrant, so we are going to work in the first and the second quadrant. Let me just get my big picture here. We are working in the first quadrant and the second quadrant. Now, that was step one. We have identified the quadrant. Now, the second step, step two, that was step one. Step two, we look for the reference angle. The word reference means we are going to refer to this angle to generate the solution for the equation sine x is equal to 0,5. And now, how do we find the general solution? We take our calculator and we switch it on. I'm having Casio FX82 ES Plus, and we press this button on your top left-hand side, and we'll be pressing shift and we press sine. By so doing, we are actually pressing the function that is on the floor there. So that will be arc sine. We refer to that as arc sine, and then we put 0,5. The Casio was so kind for me to open the bracket for me. I must also be kind to it to close the bracket. And then we press equals to, and we get the value of 0,5. So, we get the value of 30 degrees. Now, this 30 degrees, we said we have identified the quadrant. We are working in the first quadrant and the second quadrant. So we are having 30 degrees in the first quadrant, and we are having 30 degrees in the second quadrant. Observe, how do I measure my angle? I measure my angle. Let me just rectify this because I think I've made this to be a bit accurate. It must go there. I measure 30 degrees starting from here up to there. That angle is measuring 30 degrees. And again, I also start from the x-axis, measure it from here to there, and this angle is also measuring 30 degrees. Now, is this the solution for the problem? The answer is yes. The reference angle may be the solution in some instances. It may not be the solution in some other instances. As we go along, you'll see what do I mean. Now that we've got our reference angle, our third step, step number 3, step 3, we now count in an anti-clockwise direction, starting from here. Now we want our solution. We start from here up to there. Immediately when we touch that terminal ray, we count the angle there. Now, x, according to that, will be equal to 30 degrees. Now we can check if we substitute x with 30 degrees in the original solution. We press sine of 30 degrees, press it. You should be getting the answer of 0,5. Now what will be amazing is this. Press sine of 390 degrees. Oops. The answer is still 0,5. Let's try to press sine of sine of 750. Oops, the answer is still positive 0.5. Now you can see that we can get an infinite number of solutions for the equation sine x is equal to 0.5. But why or how am I getting all these solutions? Am I a magic? Definitely not. I'm not a magic. But I'm using this principle that if I'm counting from here up to there, that will be sine of 30 degrees, and sine means the ratio of the opposite side over the hypotenuse side. Now, I'm there, the ratio is this side over that long side. Now, if I rotate for 360 degrees, I'll be there. Now, I've rotated from here to there, that is 30 degrees. I rotate one revolution, I'll be there again, where the ratio is still this opposite side over hypotenuse side. Now, if I read the whole angle that I've rotated, it was 30 degrees. Now, I've rotated 360 degrees. That will be 30 degrees plus 360 degrees. That gives me 390 degrees. So I said you must press sine of 750 degrees. What I've only done is I've moved to 30 degrees, rotated one revolution, that was 360, rotated another revolution, that was 720. So 720 plus this 30 degrees is giving me 750, which gives me the ratio of 0.5, which was our original problem. Right. We said we are actually having two solutions for this. Why do we have two solutions for that? Now, if we go back to our sine graph, you have a look at your sine graph. Observe, I'm having the solution here as negative 210. Now, if I move, I'm at the top here, I'm moving down. Now I come across the solution there. Now I move along with the curve. I want the position where I'm moving down, then I'm here. If you look at this, the solution will be coming after every 360 degrees, which we use the Cartesian plane and rotated 360 degrees in an anti-clockwise direction. Again, you look at this point, I'm moving up here on the graph, and here is the solution. Now I move along with the curve. I want to be at the position where I'm moving up, and that will be the solution. Now, if you count the number of degrees from here up to there, it will be 360 degrees, which is making one revolution. That's why we are having this solution as we have x is equals to 30 degrees, or another solution, which will be, we start counting from here up to there. The solution for here will be, we want this angle. This angle will be 180 degrees minus this angle of 30 degrees. And x is equal to 180 degrees minus that reference angle, which is 30 degrees. But now, before we can go any further, we must get to a situation where I was rotating for a number of revolutions to get the general solution for this problem. Now, here we'll say I've rotated one revolution in an anti-clockwise direction. I've rotated 2 times. I can rotate 3 times, 4 times, 5 times, any number of revolutions. So I'll multiply that 360 by n. Of course, we've got negative angles as well. As you can see on this graph, we have got negative solutions like negative 210, negative 330. So to accommodate such solutions, we will say n must be an element of integers, as you know that the integers includes negative numbers, 0, and also the positive numbers. So here, for the second solution, we must also say plus 360 degrees times n being an element of integers. Of course, you get a mark to say n is an element of integer. Otherwise, you are going to forfeit some other solutions like negative solutions. Now, if we simplify the second solution, we are having x equals to 150 degrees plus 360 degrees times n. That will be the general solution for this problem, sin x is equal to 0,5. I hope you find this very easy. I want us to move to the second problem, which will be cosine of x is equal to 0,5. Cosine of x, that's the second problem, is equal to negative 0,5. Now, how do we deal with this? We follow the same steps that we have followed before, and step 1, we said we identify the quadrant. Now, we want to identify the quadrant. Cosine is negative in the second and the third quadrant. So we have identified the quadrant. Now we go to step number 2. Step 2, we've got our quadrant. Now we find the reference angle. Step 2 is I'm going to write reference angle. And remember, how do we find the reference angle? Shift or second function, add cos in this case because we are working with cosine here. And if we press that, let me just verify. Second function, add cos. The Casio is so nice to me. It has put the bracket, and then we have put comma 5 equals to. It seems like there is, okay, it seems like there is something that I've omitted when I calculate the reference angle. Many people will say, why don't you consider that negative sign? No, I'm done with that negative sign because that negative sign was just helping me to identify the quadrant. And that's it. So I'm done with it. If I want the reference angle, I just press a cos of 0,5 and the calculator gave me 60 degrees. Now we are going to work in the second quadrant and the third quadrant. So I'm going to make my terminal ray like that. And the other one like that, showing that we are working in the second quadrant. Now observe, I'm always using my x-axis to measure my reference angle. So my reference angle should be 60 degrees. That implies this angle must be 60 degrees and that angle must be 60 degrees. Now we go to the next step. Now that we've got our reference angle, what will be the next step? The next step is now to find the solution. Now, observe the reference angle. In this case, is not the solution for this problem because when we want the solution, we start from the positive x-axis up until we get to this terminal ray here. And surely this angle can never be equal to the reference angle. But if we want this angle, we refer to this angle to get to the solution for that. And I'm dropping my pen here so that you should not forget that when we count the solution, it will be 180 degrees minus this angle, then we'll have our solution there. So the first solution will be x is equal to 180 degrees minus 60 degrees. Now, you remember before we can go anywhere, I'm here, I can rotate 360 degrees, I can rotate another 360 degrees, any number of 360 degrees that I can rotate. Therefore, I'll say plus 360 degrees times n being an element of integers. And if we simplify this, 180 degrees minus 60 degrees will give us 120 degrees plus 360 degrees times n being an element of integers. Now, or the second solution, which will be, we are starting from the positive x-axis there up until we touch this terminal right here, and we must count this angle here. What is important is I'm going to drop my marker again here to foster the information that we only use the x-axis and nothing else to find the solution for this problem. Now we are looking for the whole angle here. Now the whole angle, what we know of is from here up to there we are having 180 degrees, but now we are adding another angle of 60 degrees there. Therefore, x will be equals to 180 degrees plus 60 degrees. Of course, if I'm there, I can rotate any number of revolution, I'll still get the same solution. So we can say plus 360 degrees times n being an element of integers. And if we simplify this again, that is going to be 240 degrees plus 360 degrees times n. And that will be the general solution for the problem cos x is equal to negative 0.5. I hope you are enjoying these general solutions, and we are starting with the simple ones, and we'll go to a bit difficult one as time goes on. First start from the simple, and then we go to the complex one. Now, I'm having another problem here. Now, in this problem, I make use of tan, which is a graph that is not liked by most of the students. This is a funny one. It's not liked by most of the students. However, we need to deal with it. Suppose we are having this trigonometric equation. We have got tan x is equal to negative 1. We just follow the steps that we have been following all along. We said step 1. Step 1, you can remind me about the step 1? Yes, identify the quadrant. And you should be familiar with the steps now. Right, let's identify the quadrant. Tan is negative in the second quadrant and the fourth quadrant. All students of technical college, yes, it's positive here, positive there, so I'm correct there. Now, we have identified the quadrant. It means we are done with that minus sign. Now, step number 2, we are going to find the reference angle. We are going to refer to this angle to find the solution for the problem tan x, for the equation tan x is equals to -1. Now, how do we do that? We take the calculator, we do the same thing that we have done, second function or shift. In this case, we are working with tan. I want to press -1. Oops, wrong. I've already used -1 just to identify the quadrant. So I need to press just 1 and then equal sign, and my reference angle is 45 degrees. So my reference angle is 45 degrees there, and let me just draw that. No, we are working in the fourth quadrant as well as in the second quadrant. Now something is funny here. This thing wants to be the straight line. Okay, we'll see why does it want to be the straight line. Okay, let's go back. We have got our reference angle. Let's write our reference angle. Remember, I'll drop my marker once again to remind you that we work with the x-axis. Now, to write my reference angle, I'm going to consider this 45 degrees being this angle here, and I'm dropping my marker again. I'm going to consider my reference angle as this one, 45 degrees. Now, is that the solution for the problem? The answer is no. Why? When we want the solution, we are going to start from the positive x-axis up until we touch this arm here. Then we are going to have the solution. Definitely, this is not the same as the reference angle. So our solution will be step 3. We go to our solution. X will be equals to this angle here. This angle here will be 180 degrees minus 45 degrees, which is 180 degrees minus 45 degrees. Now, we've got to stop and talk about something which is very much interesting when we are dealing with tan. You see, I'm at this point where tan is the ratio of the opposite side over the adjacent side. Of course, what makes tan to be negative in the second quadrant is because the opposite side is the y value, corresponds to the y values that are positive, and the adjacent side corresponds, the adjacent side corresponds to the negative x value. So a positive value divided by a negative value will give you a negative value, which makes tan to be negative in the second quadrant. So my point is, I'm here, I've moved from here up to there, which is the same as moving from here up to there. But now I want to rotate in that anti-clockwise direction. If I rotate like that, whoops, I come across an arm. And once I come across that arm, I must read the angle there. Okay, now that happens after how many degrees? I was here and I've rotated up to there. That happens after 180 degrees. In the case of sine and cosine, we had to rotate for 360 degrees, and in this case, we just rotate 180 degrees. Therefore, we will say the general solution will be 180 degrees times n. Of course, if we can move from here, we get there, and we'll get the same solution. So n being an element of integers. What is the problem if we don't mention that n is an element of integers? Of course, we are going to lose some other solutions like negative solutions. If we look at the tan graph here, and we want to get the solutions where the y value of the graph of tan is equal to -1, we are going to come across negative values, which is -45, -225, and if we don't specify that n must be an element of integers, then we're going to forfeit marks. Right. Then, and we can simplify this as 180 minus 45, that will be 135 degrees plus 180 degrees times n. Right. That will be the first general solution for that problem, tan x is equals to -1. Now, the second problem, or our solution x will be equals to from here up to there. Now, how do we find the solution from here up to there? I drop my marker once again and stand back so that you can remember that we only use the x-axis to generate the solution for this problem. So this angle here will be 360 degrees minus this reference angle there. So our solution will be 360 degrees minus our reference angle, which was 45 degrees. But as we have indicated, to find the general solution, once we rotated 180 degrees, we are there, we find another solution. We rotate 180 degrees, we find another solution. So we'll have plus 180 degrees times n being an element of integers. Okay, we simplify this. 360 minus 45, that will be 315 plus 180 degrees times n. Ookadok. I hope you find it interesting as we are moving deeper and deeper with these trigonometric equations. Now, let's have another problem. The problem is we must find the solution for, the general solution for sine 2x is equal to -0,5. Oops. Yes. Sine 2x is equal to -0,5. We move along with the steps. We don't behave intelligent. Step one. Who can remind us of the step one? Oh, everybody is comfortable with step one. Step one is to identify the quadrant. And where are we? Where are we? We are in the third. We are in the third and the fourth quadrant. Now, done with the negative sign. We don't have to bother again with that negative sign. Now, step two. What is our step two? We want the angle that we'll refer to in order to generate the solution for the problem. So that is our reference angle. How do we calculate our reference angle? I'll always mislead you. For a start, we press second function, arcsine or the Casio has put the brackets for me there. I'm tempted to put negative sign there. No, I cannot. Why? I've already used that negative sign to identify the quadrant. So I need to press 0,5. I must be kind to Casio, close the bracket, and the reference angle is 30 degrees there. So my reference angle is 30 degrees there. Remember, for the first problem that we have done, the reference angle was also the solution for the problem. But in this case, observe that the reference angle, which is, remember, I'll always drop my marker here so that you can recall how do we put our reference angle, and this angle must be 30 degrees, that other one must be 30 degrees. Now, to find the solution for that, we must start from, I'll put the marker there, and we count the angle from there. Once we touch that arm, we must count the angle there. Okay, now step 3 will be the solution. The solution will be, we know from here up to there, from here up to there is 180 degrees, but now we must add another angle there. So the solution will be in this case we are having 2x, not x. 2x will be equals to 30 degrees. But now we can rotate. We can rotate from here 360 degrees and come back. So, that is not 30 degrees, my mistake. That is 180 degrees. I'm writing not what I'm saying. 180 degrees plus 30 degrees. Now that we are there, we can rotate, and that will be plus. We are back to sine 360 degrees times n being an element of integer. I'll just squeeze it in there because I made a mistake there. Okay, now the solution will be, let's simplify, 180 plus 30, that is 210, plus 360 degrees times n, that is 2x. We cannot add these two numbers because they are unlike terms. This one has got n, this one doesn't have n. Now, we are not looking for the solution of 2x, but we want the value of x. So, to find the value of x, we must divide throughout by 2. 2 into 2 will go once, 2 into 1 doesn't go, it leaves 1 into 5. Into 10, it will go 5 times, plus 2 into 360, it will go 180 degrees times n. That will be the first solution. Or the second solution will be, we count from here up until we get to that terminal ray. Now, what is that angle? I'm deliberately going to drop that marker there so that you should not forget. This angle here that we have counted is 360 degrees minus that angle. And our x will be 360 degrees minus our reference angle, which is 30 degrees. Of course, we can rotate any number of revolution, and therefore we'll say plus 360 degrees times n being an element of integers. And 360, if we simplify this, 360 minus 30, that will be 330 degrees plus 300. Remember, we have 2x there. I made a mistake, I nearly made a mistake, forgotten about the 2. And then we've got 2 2x equals to 330 plus 360 degrees times n is not yet the solution. We want the solution x. To find x, we must divide throughout by 2. 2 into 3 will go once. It will make 2. It will leave 1. Into 13, it will go 6 times. It will make 12. It will leave 1. Into 10, it will go 5 times. So we've got 165 degrees plus 2 into 360 degrees. It goes 180 degrees times n. That will be the general solution for that problem. Right. So far, so good. I hope you don't have a question. If you do have a question, we'll capture that and I'll look at those questions, and in the second session I'll respond to those questions. Right. I hope everything is going well. Now, in the examinations, they are unlikely to ask you those simple kind of questions in the question papers, but what they do is they normally combine the question papers. They may combine tan with cosine, tan with sine, or sine with cosine, and sometimes they ask you about the points of intersections. Right, I think we must just pick one question here from the previous question papers and see how do they ask this question. I've got the preparatory exam 2008, and I want us to focus on question 6. And question 6, 6.1 says, express cos 2x in terms of sine x. That is a double angle. I believe you can just look at the back and get that 1 mark. That's an easy 1 mark. Now, 6.2 says, without using a calculator, oh, my poor calculator, I'm going to throw it away now. Determine the general solution of the equation cos 2x plus sine x is equal to 0. Now, it seems to me that the examiner was kind enough to lead me in 6.1 by saying express cos 2x in terms of sine x. Why do I say that? When we solve the trig equation, we must try to establish that we've got only one trig ratio. In this case, we are having cosine and sine x. Now, cos 2x is a double angle. That can be written as cos squared x minus sine squared x. Remember? Cos 2x is the same as cos squared x minus sine squared x. But now, is this going to help us? We said we want to establish a single trigonometric ratio here. Now, cos 2x is the same as 2 cos squared x minus 1 if we use the double angles. Now the question is this going to help us? I don't think this is going to help us because we'll still have cos and sine there, because this is 2 cos squared x minus 1. And cos 2x is the same as 1 minus 2 sine squared x. Now you students, you are lucky enough, you are provided with this formula sheet where you can refer at the back. I hope I have worked for 20 years with this, so they've been printed in my mind. It's not easy for me to get them wrong. So through practice, you'll also do this. Now, it seems to me 1 minus 2 sine squared x will produce the same ratio here. Now, let's have that problem there. We have got cos 2x plus sine x equal to 0. We rewrite cos 2x as 1 minus 2 sine squared x plus sine x equal to 0. So everything has been expressed in terms of sine here. We can now make a progress. Now, this is a bit complicated if it stands like this. I'm used to a quadratic equation as ax squared plus bx plus c is equal to 0. I would like to relate this to that. Now I'll be having minus 2 sine squared x plus sine x plus 1 is equal to 0. You see, I don't like the value of a as negative, so I'll have to multiply throughout by negative 1. So I'll have 2 sine squared x minus sine x minus 1 is equal to 0. Now that I'm remembering about my algebra so much, can I use my algebra maybe to factorize this? Okay. I'm going to relate this. Say we are left with 5 minutes. We can quickly say let sine x be equals to k. Therefore, we'll be having 2k squared minus k minus 1 equal to 0. We try to factorize that. I'm sure you are comfortable with the factors. Factors of 1 are 1 and 1. The middle term is minus, so the big number should take the negative sign and the small number, and the other number should take, the small number should take the positive sign. It's small because 1 times k is 2k, 2k times 1 is 2k. So I factorize that, inviting my algebra, so I'll have 2 sine x plus 1 into sine x minus 1 is equal to 0. Then I'm having my format as a times b is equal to 0. Remember, in algebra, for this to be true, a times b is equal to 0 is either a is equal to 0 or b is equal to 0. So we use the same principle there. We take this one as a, this one as b, then we'll have 2 sine x plus 1 equal to 0, or sine x minus 1 equal to 0. Transposing everything, we transpose 1 to the right, then it becomes minus 1. We divide both sides by 2. We have got minus 1 over 2, and this one we have got sine x is equal to 1. Now I think we must stop right here. When we continue in the second session, we'll finish off with this problem here. Remember, I'll check your questions if you have sent the questions here. Thank you. Welcome back. We ended up solving cos 2x plus sin x is equal to 0, and we ended at the stage where sin x was equal to -1/2 or sin x is equals to 1. Let me just have a new page. We say one of the solution is sin x equals to -1/2. Let's entertain this solution. We follow the same procedure. Step 1, we identify the quadrant, and this sign is negative, so sign is negative in the third and the fourth quadrant. And the next step will be step 2. Should be familiar with this now. Step 2, we are going to look for an angle where we refer to in order to generate the solution for that problem. So our reference angle will be, you now know that we've got to press, let's switch it on and the calculator on. We press second function arcsine. I want to press -0,5. I'm not allowed to do that because I've already used the negative sign in step number 1 where I was identifying the quadrant. So I need to press just 1 divided by 2 and then equal sign. My reference angle becomes 30 degrees. Right. Is 30 degrees the solution for that problem? The answer is no. Now, what is our solution? Our solution, I'm going to drop my marker once again, just to print this in your brain that we always use the x-axis to find the solution for the problem. So we're going to start from here. We go up to there. Oops, I must first write the reference angle. Remember, I must first write the reference angle. Our reference angle was 30 degrees and 30 degrees there. So from here up to there, that angle there will be 180 degrees plus that angle. So step 3, solution for x. X will be equal to 180 degrees plus 30 degrees. As we have indicated earlier on, we can rotate 360 degrees, come back to this same point, and rotate another 360 degrees, come back to the same point. Therefore, that will be 360 degrees times n being an element of integers. So if we simplify this, this will be 210 degrees plus 360 degrees times n. Or the other solution, we start from the positive x-axis, we rotate up until we reach this arm here, and then we're going to find the solution for that angle. How do we find the solution for that angle? It will be 360 degrees minus this reference angle there. Or x will be equals to 360 degrees minus that reference angle, which is 30 degrees. Of course, we can rotate for any number of revolutions, and that will be plus 360 degrees times n being an element of integers. So 360 degrees minus 30, that will be 330 plus 360 degrees times n. So this will be our two general solutions for that problem. Let's have a look at how many marks does it count. Oh, it's a lot of marks. It's counting 6 marks. So we are sure that we have collected all the 6 marks, because we did not forget to indicate that n is an element of integers. Otherwise, we could have forfeited 1 mark. I hope we are getting along. Let's have another problem from the previous question papers. Here, I deliberately brought along the grade 11 question paper. Why did I bring along the grade 11 question paper? Is because of the fact that, I normally get bored if I just keep on solving something that I don't know where do I use it in a real life situation. Now, here is our question 7 from one of the exemplars of grade 11. It says you go down to the beach for a few days. As an experiment, you place a meter stick in the sand to measure the height of the water. As the tide comes in, now the majority of us are living in the inland. We don't know much about the sea. The tide is when the water is getting higher. It makes what we call a tide. The height rises and then falls as the tide goes out. Then you record the heights for 48 hours. The height fluctuates. It differs between 0 centimeters and 50 centimeters. Now, that data has been collected, and the graph shows the data here. Now, that is a graph. The equation of the height of the water is given by y is equals to 25 sine 18x plus 25, where y is the height of the water and x is the time in hours from the beginning of the experiment. Now, the first question, of which we are not so much interested in, but we can tackle it: calculate the height of the water when x is 48, meaning 48 hours. So what we are going to do, we are just going to substitute x by 48 there and calculate what will be the height of the water there. Right, let's do it. We have got 25 sine of 18, and then we multiply that by x, which is 48, close the bracket, and we add 25 to it. And the height of the water will be 395. They didn't say whether it's meters or that should be centimeters. 395 centimeters. Now we are actually interested in the second question. Calculate the times when the height of the water is 10 centimeter by solving the equation 25 sine 18x plus 25 is equals to 10 for the 48-hour interval rounded off to the nearest hour. People, it seems like we did not finish that problem. We did not finish that problem. We'll go back to that problem again. We did not finish that previous problem. We'll go back to it. We did not consider other solutions. Okay, let's entertain this one. We are to solve 25 sine 18x plus 25 is equals to 10. Now, we must transpose everything to the right so that we are left with sine on one side alone. So, the first thing that we'll do is we'll transpose that 25. We'll have 25 sine 18x is equals to, now 10 minus 25 is giving us minus 15. The next step, we are going to divide both sides by 25, and sine 18x will be equals to minus 15 over 25 if we divide throughout by 25, and sine 18x is equals to, if we simplify minus 15 over 25, we get minus 3 over 5. 5 goes 3 times there, 5 goes 5 times there. Now, this we can deal with. We go step number 1. Step number 1, this ratio is negative. In which quadrant is sine negative? It is in the not second, but third quadrant and the fourth quadrant. Now we have identified the quadrant. We have identified the quadrant. Step 2, we must find the reference angle. Now, our problem is sine 18x equals to negative 3 over 5. So we take our calculator. In this case, we cannot be so intelligent. We need to take our calculator and press arcsine of, okay, here is a fraction on my Casio. Then I'm having 15 divided by, I move the cursor down. Now 15, I've simplified that. So I can just write 3 divided by 5, close the bracket. Now that was too early, I must move the cursor, close the bracket, and I'll have my reference angle. Now I must listen to the question very carefully. They said I must round off my answer to the nearest hour. Okay, we are not yet there. We can now write that as 36, 887. Let's round it off to the nearest 2 decimal, 36,87, and now step 3, we must now find the solution for x. Then we'll have 18x equals to, we go back, the reference angle here is 36,87 and 36,87 degrees there. Solution, we start from here up to there, and the angle will be 180 degrees plus 36,87 degrees. They did not talk about the general solution, So let us just leave it as it is. And the next step will be to divide. Okay, let's simplify first. Let's add 180 to 36.87 plus 180. I'm getting 216.87. That is 18x. And then we must divide both sides by 18. Then I must divide this by 18. I'm having 12,0448, which will be approximately 12,05. And another solution, or which we have actually forgotten, which I've actually forgotten to do, the second solution for that previous problem, or 18x will be equals to, we go back to our Cartesian plane, we start from the positive x-axis, we go there, and we are there. That must be our solution. So this solution is 360 degrees minus the reference angle of 36,87. Now 18x will be equal to 360 degrees minus the reference angle of 36,87 degrees. I don't think we must write the general solution for this. Now let's simplify that. We've got 360 degrees. We take our calculator, 360 degrees minus 36,87, and we get, there's a fraction, then we press SD, then we get 323,13 degrees, that is 18x, and if we want x, we must divide that by 18, divide both sides by 18, and then we get 17,95. Now, let's see if this makes sense. We look at our graph where the y value, which represents the height of the water, is 10. We are just going to estimate. You can see here is 25. Ne? The middle of that is going to be 12,5. Just below that is going to be 10. Now, if we move along here and come to this graph here, we look at that point there, we look down there. This value must just be more than 10 hours, and our answer here really agrees with us that the answer is 12,05, which will be the nearest hour. That will be 12 hours. And again, we said somewhere there is about 10, so we go there, and this also cuts this graph here. We should be having an answer that is more than 15. Let's look at our answer. Our answer here is 17,95, which will be approximately 17 hours. Let's check. 0,95 multiply by we want to make this to be the hours. We must multiply that by 60, I think. 0.95 multiply by 60. Now that will be 57 minutes, which is approximately 1 hour. Or we will say that is approximately 18 hours. And I think we are not done. We are not done. It seems to me we must also get these times as well. That will imply we'll have to look at the general solution, and by having the general solution, we just add 360 degrees times n. We just add 360 degrees times n. And here will be 323. 323, I'm trying to rectify this. 323. If we subtract 36,87 from 360, we've got 323,13 plus 360 plus 360 degrees times n. Now we have divided this value by 18 to get 17,95. Therefore, we must divide this 360 by 18. So if we divide 360 by 18, we get 20 times n. Similarly, we're going to do the same here. Divide, this will be plus 360 degrees times n. We're going to divide that 360 by 18. We're going to have 20 degrees times n. Now, you will see the importance of, which will be 12,05 plus 20 degrees times n. You will see the importance of this general solution here. Right. Now, I've just received the question that I'll respond to. You see, when I was doing this problem, I did not use the general solution. So I fell into the trap because I don't have only two solutions. I've got 1, 2, 3, 4 solutions. So the two solutions that I'm having here are not giving me the full marks. Hence, I'm adding 360 degrees times n, because originally I had the trigonometric ratio of sine there. So I'm rectifying this to get the other answers. I've actually fallen into the trap by not writing the solutions, the general solution. So my answer to the question is, in this case, we must write the general solutions. Right. We are not told to write the general solution, but when I look at this problem, I realize that we have got 4 solutions. Without a general solution, it's really difficult for me to give the other solutions in this problem. So I've rectified it and add 360 degrees. I went up to this step. So I'm having 12 hours plus 20 degrees times n. Now, I now go back. Remember, n must be an element of integer. Now, I'm going to make n, in this case, n cannot be negative, because if I've got negative here plus 12, I'll get negative hours, and we don't have negative hours. But if I substitute n with 1, 20 times 1 will be 20, plus 12, that will be 32. Now let's go back to our problem and see. Here I'm expecting the value that is, we've got 30 here. I'm expecting a value that is a little bit greater than 30. And indeed, my answer here in my general solution, when I substitute n by 1 times 20 plus 12 is giving me 32 hours, which is that solution there. Let's see if we can get another solution. substitute n by 2, 20 times 2 is 40, 40 plus 12, that is 52. Let's look at our diagram again. You see now its interval goes up to, I think it goes up to there. It doesn't go beyond 50. So that falls outside the restriction that we are having. But now let's look at our 17,95. For if we substitute n by 1, 20 times 1, that will be 20. So we said this will be approximately 18. So 20 plus 18, that will be 38. We go back to our problem and see if we've got the value there. We go along this line, we go along this line. Here, the value is 35, and obviously that must be 38. So that has been solved. Right. Now I understand why am I doing the general solution, because there are practical application of that in the real life situation. I promise to go back to that problem because we did not finish the whole problem. We ended up, I think we ended up solving only one part. Yes, I think our problem was we had the solution for sine x is equals to -1/2, but we did not have the general solution for sine x is equals to 1. Right, let's go for it. So for sine x is equals to 1, step 1, we've got to find out the quadrant. This seems to be a funny problem. The ratio is positive. Okay? Now, in which quadrants is cosine positive? That must be in the first. That must be in the first and the second quadrant. And the next step, step 2, what do? We look for the reference angle. We are going to refer to this angle to generate the solution for this problem. Now the reference angle becomes, we press second function or shift and then arc sine of 1 close bracket, and we get the answer of 90 degrees. Now, if we look at our sine graph here, the reference angle is there. We look at that and we draw the line there. It seems like we are going to have the value that is more than 360. So we should be comfortable with 90 degrees only. We'll be able to generate all the solutions for that problem. So the solution for this problem will be x is equals to 90 degrees. So let's demonstrate that. We are in the first and the second quadrant, but now the reference angle is here. From here to there, which is 90 degrees. Okay. And folks, is the same as saying we are having the ratio as positive in the second quadrant. And when we put our reference angle in the second quadrant, it will be the same line. this line. So putting one line will suffice. Now, the solution for that will be, we start from the positive x-axis up until we touch this arm. That will be the solution, but we can go for any number of revolutions. So the solution will be x is equals to 90 degrees plus 360 degrees times n. We don't have to forget that n must be an element of integers. All right, I think we are fine up to that. We are done with that question. Happy? All right. Now, let's go to the next question. And the next question will be, we have done the application, we are covered with that. We must now go to one of the question papers, I think is November, an exemplar of November 2008. You should not be surprised when I'm always announcing the 2008. I'm an old teacher, so I'm having the old material. They try to give me the things that involves the new technology. I'm totally against them, resistant, but I'll learn. I'll be there later on. Now, question 7 says, you are given f at x equal to sine to x plus 30 degrees, and g at x is equal to cos 2x, and you've got to sketch the two functions in the interval of negative 90 and 180 degrees. I think we'll do two things at a go. One of the things that we are going to do is we are going to quickly learn how to draw the graph so that we must have a picture of what we are talking about. We are going to draw the two graphs, one of f at x equals to sine into x plus 30 degrees, and another one of g at x equals to cos 2x. Now, when I look at the graph of sine x, I'm able to say this is the original graph that I'll always refer to, and this graph will generate a lot of graphs. It will produce a lot of graphs. As a result, we refer to it as the mother function because it's going to have a lot of babies. We start from here, considering the y value. The y value is 0 here, is 1 there, is 0 there, is negative 1 there, is 0 there. The next one we are expecting it to be 1, the next one 0, the next one minus 1, the next one 0, the next one 1, the next one 0, the next one minus 1. The pattern just goes on and on like that. Similarly, with the graph of cosine, considering the y values, we can start there. 0 degrees is to 1, the y value is 1, we get 0, we get negative 1, we get 0, we get 1. The next one we are predicting to get 0, the next one negative 1, 0, 1, 0, negative 1. The pattern just goes on like that. So, to be able to generate other graphs, we simply use that concept and we totally divorce our calculator. Right. Now, we want to draw the two graphs on the same set of axes. What we should be careful about, let me just get this one right. We are having the graph of g at x is equal to cos 2x. That 2 is going to affect our period, and as a result is forcing us to adjust our scale. The original graph, we used the scale of 0, 90, 180, 270, 360. So we use multiples of 90 to draw the mother function of the graph of sine as well as the graph of cosine. But now here we are restricted by these two to make another scale. Now, in order for us to sing that beautiful song of ours of saying 1, 0, -1, 0, 1, we must adjust our scale. In order for us to sing that song, we must have 0 there. Now, if we've got to sing the song, we must have 90. But if we can have 90, it's going to be 2 times 90, and it's going to be 180. It's going to spoil our song. The next thing that we are expecting is to have 90. In order to have 90 there, we must multiply that x by 45 degrees. So that gives us the scale of our graphs as multiples of 45 degrees. From 45 degrees, we'll go to 90. I must just check my restriction. I must go to 135. My scale, my restriction say, or my interval says, I must go up to positive 180. And on the left-hand side, I must go negative 45 degrees. I must go up to negative 90 degrees. That is now my interval where I must draw the two graphs. Of course, if I look at the two graphs, the amplitude of the sine and the amplitude of cosine remains 1. So I've got 1 and I've got -1 there. No problem. Now, there is another interesting issue about the first graph, which is the graph of f, which is sine of x plus 30 degrees. Now, this graph, if we're supposed to draw this graph, from the mother function, we actually trace, let's look at our mother function, we trace this point here, which is 0 is to 0 degrees. I'm sorry, 0 degrees is to 0, because we always start with x and then y. Now, we're going to trace that point using this. We say, when will this bracket be 0? This bracket will be 0 when x is negative 30. Now, we are saying this point must now move 30 degrees to the left, meaning every point will behave as such. This point will move to the left by 30 degrees, that by 30 degrees, that by 30 degrees, that by 30 degrees, that one by 30 degrees, and this one by 30 degrees. Whoops, this must be 30 degrees, that by 30 degrees, that is wrong, that by 30 degrees, that by 30 degrees. But now remember, we are restricted to draw between negative 90 and 180 degrees. So our new graph will look like this. We'll just have got to have a line there, but we don't draw it. Then we go there, follow that, and follow that, and we stop right there. We wanted to go there, but because of the restriction, we stop there. So I'm just going to estimate the values there and just draw a rough sketch of that. We must go to 90, we must go 30, and then we must go to 60 somewhere there, and then we must go to 150 will be somewhere there. Then I'm just going to have a picture of it, and it goes like that. That's a bit of, I want to get the picture of that. Then this one must go up to negative 90 there. Right, I've quickly drawn that graph. What helped me to draw that graph is because I know my mother function, and this graph is just saying it must, the new graph should move, the mother function should actually move 30 degrees to the left. How do I know that? When will this bracket be 0 degrees? When x is negative 30 degrees. So I'm actually tracing this point here 0 degrees. Then I want to see what will be its movement. Right. Now, we draw the graph of cosine. Now, I said we must now sing that nice song, 1, 0, negative 1, 0, 1. Now that I've got my nice scale, I can sing that song, and let me have another color here. I'm ready to sing the song. I'm having 1, 0, negative 1, 0, 1. I'm tempted to say 0, negative 1, 0, 1. But I cannot do that. I'm restricted to work up to 180 degrees. So I join this set of points. This will be my curve. I'm not talking about that curve. Right. Now I've got the two graphs. One graph is the one of sine, which is f at x, and this other one is the one of cosine, which is g at x. All right. Now, we were actually not interested in that. I just happened to touch that because I like it to draw the graphs from the mother function and also to visualize my solution. Now, the main problem here that we are given is 7.2, which says calculate the values of x for the y value of the graph of f to be equal to the y value of the graph of g. Now, if we look at the two graphs here, the y value of the graph of f at this point is that one, and the y value of the graph of g at that point is that one. Again, this happens here. The y value of the graph of f at that point is that y value, and the y value of the graph of g at that point is the same y value. So if the y values f at x is the same as g at x, the left-hand side is the same as the left-hand side of that. It means the right-hand side must be the same as the right-hand side of that. Now we have made a progress. Sin x, x plus 30 actually, equals to cos 2x. But now we cannot work with different ratios. Now what if I divide both sides by cosine so that I must simplify my things? You are just going to complicate the issues. We cannot do that. These angles are not the same to start with. Right. Now, angles because I see cos 2x there. What if I go that route? Well, you are still going to complicate issues. The best way is you can express cosine in terms of sine. And how will we do that? Let's have a look at the graph of, we want to draw the graph of, suppose y equals to 90 degrees minus x. Now, I'm sorry, y, not that one, y equals to cos of 90 degrees minus x. That is what I wanted us to draw. Now, in order for us to draw this graph, we must understand our mother function. Our mother function, of course, is this one. And then we ask ourselves a question, when will this bracket be 0? We know at 0 degrees, the y value is 1. So we are now tracing this point 0 degrees is to 1. And x must, if this bracket must be 0, it means x must be equals to 90 degrees. Okay. Now, if x is 90 degrees, what will happen? It means if x is 90 degrees, every point of this graph must move to the right by 90 degrees. Whoops, I'm not sure of what I'm talking about. I must now make a plan. I must make a plan. Right, I'll just say 90 degrees minus x. I want to make it to be 0. So solving for x, I'll have minus x equals to minus 90. Now multiplying or dividing by negative 1 on both sides, x will be equals to 90 degrees. So it means every point must shift to the right by 90 degrees because this is positive. So if we've got to do that, this point must move there, this point must move there, that point must move there, that point must move there, and we'll be having this kind of a sketch. Remember, we've got that point that must move there, that point that must move there, and we've got that kind of a curve. So I'm quite sure that I missed something here, which will be this line from here up to there. Okay, folks, we took too much time, but I'm sure you'll be able to handle this one. We are going to rewrite this sine into x plus 30 degrees, and cosine, we just rewrite it as sine into 90 degrees minus 2x. Now we are going to follow the same steps. Step 1, we're going to have quadrant, that will be, this is positive, sine is positive in the first and the second quadrant, and we're going to do that and that. And because we've got x there, we are not going to calculate the reference angle, which will be step 2. We are just going to write the reference angle as 90 degrees minus 2x and 90 degrees minus 2x. Solution, that will be that, plus 360 degrees. Another solution, that will be 180 degrees minus 90 degrees minus 2x. We'll find the solution there, and we'll be able to finish off there. I don't think that is very much difficult. Thank you very much. We can now entertain the questions. Okay, let's go to the questions. The first question was asking about on how to find the reference angle, especially on that question of grade 11. This is going to be really a mathematician. He or she is interested in practical things. So we had sine 18x equals to minus 3 over 5. So we said we are done with that minus because we have identified the quadrant. That is now step 1. That was sine is negative in the third and the fourth quadrant. So we are fine with that. So what we need to do is to find the reference angle. To find the reference angle of that, let me switch my calculator on. We press shift or the second function. we are working with sine, so that will be the arcsine. That function on the floor there, when we go to shift, we'll be pressing that function which is called the arcsine. The Casio is so nice to open the bracket for me, and then it has got the fraction as well. But if you don't have the fraction, no problem, you can just say 3 divided by 5 directly. So I'll say 3 divided by 5 and move the cursor to the right, close the bracket, and I'm getting 36,869, and I think I decided to round it off to do 2 decimal places as 36,87. Now, the very interesting question, I think this question came before I finish off here, which is very crucial, was how do I know whether the graph is shifting to the left or to the right? Now, suppose you are having the graph of y is equal to sine into x plus 30 degrees. Now, we are saying, when will this bracket be 0? Why are we referring to 0? We are actually tracing this point here. This point. What will happen to this point if there are some changes? Now we draw x is equals, y is equal to sine of x plus 30. We ask ourselves a question, when will this bracket be 0? So when will x plus 30 degrees be equal to 0? Is when x, if we subtract both sides, we subtract 30 on both sides, we'll end up having the right hand side as x is equal to minus 30. It means our mother function, for every point that we are having there on the graph of y is equal to sine x, every point must shift to the left. Why to the left? Because of this negative sign here. Then we shift every point to the left. Suppose we are having y equal to cosine of x minus 60 degrees. We want to draw that graph. When we draw that graph, we look at our mother function, the graph of cosine. We are actually tracing this point, 0 degrees is to 1. What will happen to that point? And if we work with that point, we'll say, when will this bracket be 0? So when will x minus 60 degrees be 0? It means when x, if we add 60 degrees on both sides, x must be equal to 60 degrees, and this 60 degrees is positive. It means every point of the mother function will shift by 60 degrees to the right. This point will shift there, this point will shift there, this point will shift there, and so on and so on and so on. That's how we know where does the graph shift to, whether to the left or to the right. Now, and this question has been asked before, and I'm trying to find the question. I'm trying to find the answer. The answer for this will be, in this case, of which is one of the problems that we haven't done, they have said calculate the x coordinates of P and Q. As I've indicated, we are only going to get this, the two solutions for this problem, P and Q. But if we've got lot of solutions that we've got to find out, in the case of that grade 11 problem, we had 4 solutions. If we've got to get more than 2 solutions, we've got to give the general solutions. Or if the 2 graphs are cutting each other for more than 2 times, we've got to give the general solution. The general solution is making things easier to calculate the points of intersection, or where the 2 graphs are intersecting each other. I hope you have enjoyed this session. Thank you very much. Up until we meet next time. There is a question from Rampine, which is very much interesting. She is asking about the effect of, say for instance, we've got y equal to sine 2x. The effect of 2 next to x, will it change the shape of the graph or not? Yes, it will. Look at our graph of sine, for instance. We have got y equal to sine x, and we are able to follow this pattern: 0, the value of y as 0, 1, 0, negative 1, 0, 1, 0, negative 1. So in order for us to draw the graph of y is equal to sine 2x, we will like to have the same pattern of saying 0, 1, 0, negative 1, 0, 1, 0, negative 1. Now, in order for us to have that pattern, in the original graph, we are having multiples of 0, 90, 180, 270, 360. In this case, we'll have 0 degrees there, but the next multiple that we must have that will give us 90 degrees must be 45 degrees. The next one must be 90 degrees. So this is changing the scale of the mother function. The period of the graph is going to come very quick. That will be 135 degrees. That will be 180 degrees. That will be 225 degrees. I'll not finish the whole thing. But now, as you can see, we must say 0, and then we say 1, 0, negative 1, 0, 1, and we try to join those points. As you can see, the period for that graph is between 0 degrees and 180 degrees. That has actually affected the period of our mother function, because our mother function had a period. I'm going up above the x-axis. When will I again go up above the x-axis? There I go, there I go, there I go. Then I'm starting to make the same thing here. So the period, the original period of our mother function of sine is 360 degrees. But this one, the new baby, the newborn, sine 2x, will be equal. So I'm going up above this x-axis. When will I again go above the x-axis? I'm going to stop here. Otherwise, I'm going to do the same thing. So that period of y is equal to sine 2x is 180 degrees. And indeed, this 2 has changed the period of the mother function and make it to be 180 degrees. Thank you. A very nice question, Rampine.